All right, so last lesson we were doing the tan ratio or the tangent ratio. So tan theta was equal to opposite over adjacent. Now what we're going to be doing is the sine ratio and the cosine ratio. And I'll show you where we're going here. So in the last one, this was our adjacent, if this was the angle we're looking at. If this was our adjacent and this was our opposite. Did you guys notice in the last lesson we were only ever using this side and this side? Right? The opposite and the adjacent. Did you notice that we just completely left the hypotenuse out of it? Well, that's what we're doing now. With sine and cosine, all we're going to do is we're going to be bringing in hypotenuse into it as well. So I'll give you a hint. Our sine ratio is going to have something to do with hypotenuse, right? But it'll be like, yeah. Yeah. And if the other thing, guys, just take a look at your calculators. So you found where the tangent ratio or a tangent button was. Can you guys right now just find where the sine and cosine button are? The three of them go together, right? Sine, cos, and tan. They're all a family, right? So that you'll get used to using them. And then you should also see like somewhere it might be like sine like -1 or something like that, like the inverse of sine, inverse of cos. Yeah, so those will all be there too. Like I said, they're all kind of different, so we'll kind of work on where yours is. Oh, that should say lesson 14. Sorry. Okay. So good news is there's going to be a lot of the same as last time, but now they just have different ratios. So this part we just did, right? The tangent of the angle theta, like in this case, was the ratio of the opposite side, like the blue side, over the adjacent. Now the new ones we're bringing in, so the sine of the angle is going to be the opposite, the length of the opposite side over the hypotenuse. And the cosine of the angle is going to be the adjacent over the hypotenuse. That's really it. We're just like changing up just what the ratio actually is. So now you guys actually have this on your formula sheet too, like which ones they are. So you'll always have that. But I don't know if you've ever heard other kids at school saying this though too. It's a really common way of memorizing these things for trigonometry. And it's called SOHCAHTOA. You guys ever heard that word before? So, or it's not really a word, but this is what it is. So you'd write S. Can you guys write this down too? So it'd be S O over H C and then A over H and then T is O over A. Do you guys see why we call it SOHCAHTOA? It's like SOHCAHTOA. Yeah, yeah, okay. All right, so why this is helpful is because you like you'll see kids in like my other classes, they'll write this all over the page, right? Every time they do a question, they write this down, and it just helps you figure out which one we need, whether or not we need sine, cos, or tan, right? Okay, but first off, let's practice our labeling from last time. So in order to figure this one out, we have to label this thing properly with our adjacent, our opposite, and our hypotenuse. So like I said, a good place to start is to figure out where your opposite is. So start with your angle, right? So if we're at our angle, can you guys right now just take a guess where do you think the opposite would be? Like write it down on your page. All right, so I'm going to start with my opposite. That's on the opposite side of the angle, right? So this will be my opposite. Okay, my adjacent, what do you think? Bottom or top? Bottom, right? This will be my adjacent on this side. And this will be my hypotenuse. Oop, that was weird. Okay, now what about the next one? I'm going to pause it. Can you guys label this one? Did anybody get this one? Yeah? Okay, good. A mistake that people might make, just so we can avoid it now, is they might have had these backwards. All right, they might have called this the adjacent and this the opposite. And that would be if you were looking at this side as the angle, right? Then that would, yeah. So that, oh, that I wrote that the same way, didn't I? I wrote the same thing. Sorry. They might have had it as this as the adjacent, and this is the opposite. And what that is, if you would have been looking at this angle, then that would have been true. Do you guys see how it depends on which angle you're looking at, right? The adjacent and the opposite will switch depending on which angle you're looking at. So since we were looking at this top angle, that's the opposite, and that's the adjacent. Okay. Okay, so let's, I'll skip through a couple here because they are kind of similar. Let's do this one, like the very last one here. Commit to the side names. Like, what do you think? All right. So this is what we ended up with. So it's upside down, right? So sometimes it's hard to see, but this is still my adjacent. The opposite still on the opposite side of the angle. So yeah, we're good to go. Okay, why that's probably one of the more important things for us to get figured out, because as we start solving these, we really need to have them labeled properly. So let's solve this one now. It's going to be just like the tangent ratio, but it'll just be either sine or cos this time. All right, here's how we're going to do it. I want you guys to write this down as SOHCAHTOA. SOHCAHTOA. Step number 2, we got to label our sides of our triangle as opposite, adjacent, or hypotenuse. So if this is the angle we're looking at, that would make this the opposite. The adjacent would be that one, so ADJ. And then this would be our hypotenuse. Okay, so now we have, well, now we have to figure out which one we're using, whether or not we're using sine, cos, or tan in this problem. So we pretty much look at and see which ones we're interested in. Can you guys tell that we don't even care about the opposite? It's not even in part of our equation, right? We want the one that has hypotenuse in it and adjacent, because those are the ones we need to involve here, right? So which of these three deals with hypotenuse and adjacent? C, right? So cos. So that's step number 1. That's probably one of the harder parts, is just we have to figure out which one to use. So now that we know it's cos, we're going to write it out. So we'll write it out as cosine 34 degrees, right? Cos of the angle is equal to, and then it's adjacent over hypotenuse. If you want, you could have put the numbers right in, or put them right in right away, but I'll do it on the next level down. And here, probably should have just wrote down our equation. So cosine theta is equal to that. We'll put that in the next one. Okay, next row down, we're going to say, okay, cosine of, and now this is 34 degrees, is equal to, all right, so what's my adjacent? X, right? That's what we're looking for, so I'll just keep it as X. Over, and then what's my hypotenuse? 13. This looks really similar to the... Cos 34 times. Yeah, it will be in the end. Yeah, so in the end here, we're going to multiply both sides by 13, right? So the 13 comes up. But do you guys see, again, what happened? The 13 was on the bottom over here, and then it just moved up there, right? That's like a nice little trick we can use to rearrange these easily, right? So that's it. So you just need to type in 13 times cosine 34 degrees. So can everybody find those buttons on their calculator? Okay. Okay, so now typing this in. So this will just be, on this one, like if you have a calculator that you can just type it in just like this, that's handy. If not, and I think mine's like that, I have to type in 34 and then cos, so function, nope, trigonometry, cos, right? So now it took cosine 34, and then I'm going to go that times 13 equals.
Okay, that's what mine has to do too.
Yeah, so now I got 10.8. So 10.8 is equal to x. That's it. Okay, let's do some more. Actually, you know what? Now that we've done this, I'm gonna let you guys give it a try. We're gonna just do a bunch. Well, you know what? Here, I'll do one, and then we'll go from there.
No.
Okay. So looking at this one, we've got our angle here. So that would make this my opposite, this my adjacent. No, sorry, what am I doing? This my adjacent, and this my hypotenuse. All right, and then we can write down SOHCAHTOA. Okay, so if I'm looking for y, and I have the hypotenuse, I'm looking for the one that has hypotenuse and opposite, right? So which of these am I yeah, so I'm looking for s, right? So perfect, so it's going to be sine. So it's going to be sine theta is equal to, my opposite is y, my hypotenuse is 16. And I could have put, here, make this easier, sine 16 degrees. Okay, you guys maybe seen the pattern here. This 16 will go up. So this is really just 16 times sine, oh, sorry, that was 15 degrees, sorry. 15 degrees is equal to y. Okay. So I'm going to go, yeah, 15 sine, so now I have sine 15 times 16 is equal to 4.1, yep. Is equal to y. And then just check if it makes sense, right? If that's 4.1, or 4.1, right? Yeah, that does make sense, because this is a small angle, right? So I'm expecting that this backside would be, you know, quite a lot smaller than 16, right? All right, I'm going to pause it. I want you guys to do the next one. Sorry, I kept it paused there. So here was the answer for that one. Check your work if you're watching the video. Okay, moving on to 3. So if we're looking at this angle, let's label it. So that's going to be my opposite side, which would make this my adjacent, and this one will be my hypotenuse. And if I SOHCAHTOA it, then, okay, which one do I want? Sine, cos, or tan? Cos? Yeah, how'd you know it was cos?
Because it uses hypotenuse and the
Yeah, those are the two I'm interested in. I don't even care about the opposite, so I'm going to use cosine, right? Because that's adjacent and hypotenuse. So it's going to be cosine of 42 degrees is equal to, and then cosine is adjacent over hypotenuse. So now we've got 17 over m. You guys see the new kind of problem here? Now the variable's in the bottom. You guys remember how we deal with this from last lesson?
I think you times it by n and move the n in front of the cos, and then you divide cos by itself and 17.
Perfect. Yeah, that's what's really happening. You like multiply. Really, what's really happening is we're going to multiply both sides by m, right? So I get m up there, and then we divide both sides by cos 42, and it comes down. But a nifty little way of rearranging this is we can just swap the m and the cos 42, right? The m goes up, the cos 42 comes down. Yeah, so then we just get m is equal to 17 divided by cosine 42. Okay, so now putting that in. Okay, so I'm going to have to, I'm going to go 17. If you have a calculator like mine, like make sure we do these steps. So it'll be 17 divided by, and then again we have to type this in as 42 cos. And then I'm not quite done because that's what 40, like cos 42 is the number in there. I have to push equals again at the end. So that's going to be 22.9. We'll round up to 9. Or 23 even, right? Just round it to 23. All right, your turn. So I'm going to pause it, give it a go. Okay, so if you're watching the video, there's the answer for that one. Okay, last one here now. We are going to work on solving for the angle. Okay, so we can solve for the sides. I think we've done like quite a lot of that now. Now we just have to work like, what if we were given the angle like this? How would we solve for that if we had 2 of the sides? Really similar process. So there's good examples here. Let's go down to the practice problems. Okay. So same idea. I'm going to get you guys to write down SOHCAHTOA. SOHCAHTOA. Okay, let's label this thing. So the same thing, that's my angle, right? I don't know the angle yet, but that's still the one I'm looking at. So that would make that the opposite. The one beside the angle would be here. That's the adjacent. And then the hypotenuse is the longest one, so that's going to be this one. All right, so now we got like a similar situation as before, is that we got to figure out which one we're going to use, sine, cos, or tan. Yeah, right. How'd you know it was cos? Right. Yeah, exactly. So we know this thing's going to be cos because we got the adjacent and the hypotenuse, and I don't even care about the opposite. So I want the one that doesn't have opposite in it. Yeah. So this will be cosine, and I'm just going to leave it as theta because I don't know what it is equal to, and then just get this in the right order. It's going to be 13 over 17. Okay. So now the issue is I want to solve for that angle. The problem is that right now cosine of the angle is equal to 13 over 7, but I don't want cosine of the angle. I just want the angle. So I have to like uncos it. I have to like decos this thing. You guys remember how we like untanned it last time? Yeah, it's that -1 thing, right? So on your calculators, you guys have that button, right? So the way you would write this out, though, this is technically how you would write it. It would be theta is equal to cos -1, which is like the inverse of cos. It's like the opposite of cos, of 13 over 17. Okay? So no more algebra. These ones are a little easier even because we don't have to do any algebra. We just got to push the right buttons. So on your calculators, again, they'll all be kind of different. So I'm going to type this one in as, so on this one I have to do the inside and then go cos -1 of that. So I'm going to go 13 divided by 17. And I'm going to go equals, right? So now I have that decimal, right? That's what the inside is. And now I'm going to go my trig function. And this one I have to push second. And then cos -1. So yeah, so it's looking at, I don't have to push equals now because that's all I have up top. So now like, I can even see that it's saying cos -1 is equal to that. If I push equals again, it'll probably do that operation again. So that's just good. So my angle here would be 40.1 degrees, was it? Yeah. So then that's good just to say 40 degrees. And just again, make sure that kind of makes sense. That does kind of seem like about 40 degrees. Yeah? Cool. All right, your turn. Okay. So that was the answer for that one.